Critical minerals and rare earth elements are few of the areas which are always in news and which have been prominently being discussed in geostrategy in terms of national security as well as self-dependence for the past couple of years. This naturally makes it very important not only for your examination but also for the long-term growth of any particular nation. From US to China to India to European Union, every region is investing very heavily in these critical minerals and rare earth elements. But what are these critical minerals? What are these rare earth elements? Where are they found? What are the policy structures and the bottlenecks which are present across the world? The global distribution, the largest presence in which areas? And also, what is it that India is doing in order to improve its presence in this area? Along with these examples like lithium and cobalt, in this particular session, we shall be exploring all the details of it from basic to proficiency. Hello and welcome to An Academy. Welcome to the session where we shall be discussing from 0 to 100 of critical minerals and rare earth elements. What are they? Where are they found? And also the policy imperatives associated with them. It is one of the most important areas that you can think about, be it for the prelims, be it for the mains examination. So, this is an area you must pay attention to. Now, what is it that we are going to discuss in this particular video? What do we understand by the term critical minerals? Which are the minerals which are categorized as critical minerals? We are not going to rectify these critical minerals, rather, we are going to understand the pattern. Which one are them? There is a separate type which is known as the platinum based minerals, separate type known as the battery based minerals. What are those? Then we are going to discuss about some of those minerals, like, for example, lithium, cobalt. What is their usage? What is the global distribution? How is it that lithium mining is done? That will help us understand why across the world there has been a kind of a lagging in interest in terms of mining of lithium, but now it is picking up. Which are the largest suppliers and the largest reserves of lithium across the world? Then we will concentrate upon the case of rare earth elements, the type of rare earth elements. Do you know there are two different types? That is, the light rare earth elements, heavy rare earth elements. Neodymium, dysprosium, what is their use? What is the global distribution? And where does India stand? Thereafter, we will take a look at the issues facing these elements across the globe. Their utility is obviously something that we are going to be discussing. And after that, the policy pyramid. Now, what is this policy pyramid? That is from the acts to the case of the National Critical Minerals Mission 2025, to the case of the critical minerals or the rare earth element corridor, which has been announced in this year's budget. So, this is going to be the purview of our entire discussion, starting first of all with what do we understand by the critical minerals themselves. So, the name critical, what does it indicate? So, these are the raw materials, minerals, metals included, which are very, very important, for example, for the growth of any particular nation in the renewable energy sector, in the clean technology sector, and a transition to renewable energy. For example, right now across the globe, there is an increased amount of focus and prominence of burning fossil fuels. Now, everybody is focusing upon transitioning to green energy. But for that green energy, you need better quality of wiring, better quality of battery storage structures. And for that, you need these critical minerals. Various different minerals like lithium, vanadium, cobalt, rare earth elements included, nickel, gallium, platinum, all of them are a part of critical minerals. Yes, you have heard correct. Rare earth elements are a part of critical minerals. They are not separate. They are in the larger subset of critical minerals. So, if this is the entire series of critical minerals, rare earth elements are just a part of it. There are other elements as well. Which are those other elements? So, let us understand that with the help of the simple periodic table that you would have seen from your childhood days. Now, here you see multiple different shades and multiple different colorations within the periodic table, right? Now, if you analyze them, first of all, What are critical minerals? Minerals essential for economic development and national security, because they are used in defense tech, in aerospace, in medical tech, everywhere the utility is there. So, here, for example, you have battery minerals which are used in storage batteries, which will be very important for renewable energy sector. For example, if you have solar power, now solar power will generate energy during the day, not during the night time. So whatever energy is generated during the day needs to be stored in those reliable batteries. There you use minerals like lithium, cobalt, nickel, right? You have the lithium ion batteries, cobalt based batteries, and so on. Then you have got the technology and industrial minerals, which are used in precision industry, which are used in higher end technological input. So, titanium, vanadium, zirconium, niobium, hafnium, tantalum, tungsten, and then the semiconductor based silicon, germanium, gallium, thallium, lead, bismuth, right? All these are basically technology and energy industrial minerals. Other than that, you have the platinum group minerals: ruthenium, rhodium, palladium, osmium, iridium, and platinum. These are also part of your critical minerals. Other than that, the rare earth elements, along with scandium, and yttrium. So the rare earth elements, that is the lanthanides, all the lanthanides, right? Which are rare earth elements. They are also a part of the critical minerals cohort. So all these are your part of critical minerals. USGS, that is the Geological Survey of US, has also singled out some of these critical minerals. Around 60 of them have been identified. India has also roughly arrived at the same list. We will take a look at that list. But before that, here, if you observe it with the periodic table, you will be able to correlate to it. You have these 60 critical minerals. Now, here, from aluminium, antimony, all of them, they are included. Now, can you and should you remember all of them? No, just get a broader idea with the help of the periodic table. Now, here, for your convenience, you have the critical minerals by category as well. Which of them are energy transition, which of them are battery minerals, which of them are rare earth elements. So, all of them are a part of the critical minerals. So, this has been largely the list which has also been finalized by the Indian government. Now, let's take an example of a couple of them. Lithium is always in news because of lithium mining, the concentration of refining in the region of China, and also India's quest to get as much amount of lithium as possible for supporting its own homegrown battery base and the PLI scheme that India has launched in order to develop Atmanirbharta in the battery development. Now, before we move into that, a quick announcement for all of you. We have come up with a lucrative offer if you are intending to prepare for the civil services. Now, there we have a price of 19,999, flat 50% off, and get a free extension of 6 months. Now, if you are unable to pay it all at one go, to make it pocket friendly, starting at 833 per month, all you need to do is apply the code IS English and ensure that your entire syllabus is finished in a timely manner. You are disciplined enough and you are able to clear the exam in one attempt and not remain an aspirant throughout your life. So use this code and avail this wonderful opportunity. Having said that, let us take a look at one of the important critical minerals which is always in news, and that is the mineral of lithium. Now, lithium basically has got its use in a diverse region and a diverse field, starting from the lithium ion batteries, ceramics and lenses, pharmaceuticals, right? Because the salts derived from lithium are used as mood stabilizers in drugs as well. So that is where even in pharmaceutical industry they have an increased use for treating bipolar disorder, depression, and other mental disorders. The drugs that are used, they do utilize lithium. That is something that you must not be aware about. Now, these kind of statements are oftentimes framed in the multiple choice question offered in the prelims exam. Other than that, thickening agent, right? For lubricating greases to be used in high temperature, for example, heavy machineries, right? So, there, lithium is used as a thickening agent. Now, this is the utility of lithium. But where is lithium found across the world? So, if you take a look at the lithium, where it is present in terms of reserves, so largest reserves are present in Bolivia. Largest reserves are present, but does not mean Bolivia is the largest producer. So, Bolivia, Argentina, US, Chile, Australia, then comes China, and then comes India. Now, Bolivia, Argentina, and Chile together, they are known as the famous lithium triangle. ABC, remember that. Argentina, Bolivia, and Chile. They form the lithium triangle. Now, here you will observe the larger producers. Now, who is the largest producer of lithium in the world? Australia. So, producer is not dependent upon who has got the largest reserve. For example, Bolivia has got a very large amount of reserve, but not everything is extracted, right? They don't have the technology, they don't have the money to extract everything out of it. Australia, whatever reserves it has, it is able to extract all of it. Then comes Chile, then comes China, and then comes Argentina, right? Now, China is not such a larger producer or extractor of lithium, but then why do you hear the news story that China is dominating the region of or the area of lithium or the mineral associated with the supply of lithium? That is because majority of the lithium produced in the world reaches China for refining purposes. In order to make it utilizable for industry, the lithium which is extracted from the mines, that needs to be refined. It needs to be processed. And China has been developing this capacity not since the past 4 to 5 years, but for the past 2 to 3 decades. While the world ignored and the world was still not aware about the utility of lithium to such an extent, at that point of time, China had framed a policy for the extraction and the refining of the critical minerals. Now, India also has got reserves of lithium. Now, it made news headlines when lithium reserves were found in the Riyasi district in Jammu and Kashmir. Other than that, lithium reserves in India can also be found in Jharkhand, Arunachal Pradesh, Meghalaya, Nagaland, Chhattisgarh, and Rajasthan. Right? These are the areas where lithium reserves can be found in India. So, Jharkhand and Chhattisgarh, Arunachal Pradesh, Nagaland, and Meghalaya in the northeastern part, Jammu Kashmir, and Rajasthan. Some parts in the region of Karnataka also have got the presence of lithium. But then the exploration has not been done to such an extent. This has been one of the problems that India faces in the extraction of critical minerals. That is, exploration is limited. We don't have sufficient technology or efficient technology to extract all of it, and thereby we have lack of supply and we are import dependent. But then why is it that the world did not concentrate so much on lithium extraction and suddenly the world has realized, whereas China stole a kind of a march in this area? That is because extraction of lithium is a very polluting process. Here, what you see in the screen is a very systematic and a schematic image of lithium extraction. So, large amount of lithium reserves are to be found in the salt pans and in very large areas. For example, you would observe in South America, you have these large saline water bodies like Salar de Uyuni and such areas. Salar basically represents the saltwater lakes. Now, these are where you have the brine solution. The brine solution is referred to where you have a heavy amount of salt presence. So, those brine solutions which are prepared from where evaporation is carried out and lithium is then left as a residue and is extracted. So, here you observe basically that you have the nearby areas of the hills, the various different types of plateaus, uplands. Now, during rainfall, there is a runoff which is generated, right? Runoff which is generated. Now, this runoff oftentimes that brings in some amount of lithium which is present in these rocks and that gets accumulated in these water bodies. Okay. Now, these water bodies in these drier areas, so in China also, where is it found? It is found in western part of China, the Xinjiang region, right? So that is where you have the lowest deposits as well. So it is a dry area. In drier areas where there is a lot of evaporation, salinity factor increases. Slowly and steadily, some of that seeps in. Okay. Now, after that, here you will observe that basically lithium rich brine is extracted from the underground. All this lithium from the surrounding has reached the underground. It is extracted, moves to a pumping station. From the pumping station, it is put in large pools. You see these segregated pools. So here you have lithium rich salt solution which are spread in these pools. Here, water is allowed to evaporate. After that, you have a mixture of many different compounds along with lithium, which are left as a residue. Now, these residues, in the case of critical minerals, they are also known as tailings. Tailings. Oftentimes, they are also known to have some of the other minerals which can be utilizable, some of the other critical minerals as well. Then, after this, basically, whatever is left is transferred into lithium concentrate ponds. Okay. From there, basically, you have the pumping station, and lithium depleted salt solution is then injected back. In the meanwhile, this lithium concentrate pond transfers that solution into lithium brine processing plant, and then it is transferred basically into other areas of a larger processing plant where the refining process is done. So it is that refining process where China has got a greater proficiency, and that is why majority of the refining which happens across the world gets channelized to the region of China. Now, this entire process is very polluting to the environment. Extracting this lithium, the residues which are then dumped outside, because other than lithium, there are other salt mixtures as well. They are simply dumped out in the atmosphere or in the ground surface. That is considered to be very polluting. That is why countries like US and so on, and European Union countries as well, despite having the technology, did not enter into the lithium extraction and mining through the 80s and through the 90s as well, whereas China did, because this was to be found in that region of China where, anyways, population is very less. That is the western part of China. Okay, so this was about lithium. What we have seen: utility, areas of deposits, which is having the largest deposit, Bolivia, which is the largest producer, Australia. Okay, and we have seen where in India it is found: Jammu Kashmir, Rajasthan, Jharkhand, Chhattisgarh, Arunachal Pradesh, Nagaland, and Meghalaya. These are the areas where typically lithium is to be found. Then take another case of critical mineral, that is cobalt. Now, cobalt with an atomic number 27, obviously, you don't need to remember that, but it is used in jet engines. They do not undergo corrosion. So, that is why cobalt based alloys are used in the jet engines. Now, think about it. Global aviation industry is growing. Indian aviation industry needs to grow at an explosive pace. We need the jet engine technology, and for that, cobalt is an important key mineral. Now, there it is also used in medical ground. So, for example, radioactive cobalt 60 is used to sterilize the medical equipments. It is also used as a coloring pigment agent in porcelain designs and so on. So, cobalt also has got multifarious utilities. So, like that, you have multiple different rare earth critical minerals, including copper, which is considered to be transition mineral. Now, coming to the rare earth elements. Now, what are these rare earth elements? So, basically, a group of 17 chemically similar metallic elements, that is the 15 lanthanide group, we will see again, plus scandium and yttrium. That is, you see scandium, yttrium here, and then the lanthanides. These are your rare earth elements. Okay. Now, these are your lanthanides. The group of these 15, these are your lanthanides. Now, there is a classification of the rare earth elements into the light rare earth element and heavy rare earth element. So, from lanthanum, cerium, praseodymium till samarium, this is known as the light rare earth elements. Whereas from europium all the way till lutetium, that is known as the heavy rare earth element. This is a classification that becomes important for your prelims examination of rare earth elements. Rare earth elements are a part of the larger substructure of critical minerals. Okay, they are a type of critical minerals itself. Now, why are they referred to as rare earth elements, by the way? And their utility is again multifarious. From high end technologies, for example, in satellite tech, in aerospace, in defense tech, radar technology, everywhere you have the use of rare earth elements. Remember, Donald Trump, when he wanted to impose sanctions on China, he was not able to do so. He did impose sanctions on India. He did impose sanctions on almost every other country that he wanted to. He could not impose sanctions on China. And the reason behind that? Because China has got a heavy amount of rare earth element presence, refining capability, and production. For example, you see, magnets. Magnets are in use in automobile industry, in electrical industry, and so on. Even in transportation, for example, Chinese engineers have developed the maglev trains, which can move at very fast speed. There also use of magnets is there. Now, one of the strongest magnets known to mankind is neodymium, made out of neodymium, which is a rare earth element. Now, that is something which is present in abundant quantity in China. It is present in Brazil as well, but Brazil is not able to extract it completely. China is able to extract it, refine it, and make these rare earth permanent magnets as well. Owing to that, Indian government in the budget this year has launched a separate program for the rare earth permanent magnets. We'll take a look at it shortly. But this tells you about the importance of these rare earth elements, clean energy systems, wind turbines, electric vehicles, high-tech technologies. Everywhere, rare earth elements are used. Now, this is a list, a compilation of the list of these rare earth elements and their overall utility. You will find a pattern, right? These are all these rare earth elements. So, for example, scandium, superalloys, right? Aerospace components which are very, very light. In aerospace, you do require components which are strong but not heavy enough. So, for that, you need this X ray tubes, baseball bats, light, semiconductors. We have a greater requirement of semiconductor, as does the rest of the world. Yttrium, metal alloys, rechargeable batteries, then high temperature superconductors, which are in greater use even in quantum tech nowadays. Then lanthanum, batteries, refining catalysts, camera lenses, right? Cerium, then praseodymium. Praseodymium is again used in magnets. Very strong magnets are developed because of and from praseodymium. Then neodymium, high strength permanent magnets, lasers. Lasers are nowadays used even in defense technology. For example, in anti drone warfare, DRDO has also developed laser technology for anti drone warfare, where just by emitting laser rays, you are able to bring down the drones. That also does require neodymium, right? Lasers, infrared filters, hard disk drives, like that, samarium, the europium, terbium, all of these you'll find have greater utility in the cutting edge technology, in the modern day technology. That is why rare earth elements are of great use. But why are they known as rare earth, by the way? We started that. So, are they available in lesser quantity? Is it the reason why they are known as rare earth elements? No. They are present in substantial quantity. Across the planet Earth, they are present in substantial quantity. But then, why do we refer to them as rare earths? Because at one region, they are never to be found in great amount, right? For example, let's suppose you have a region. Now, if let's suppose gold is to be extracted. Now, in this area, if you have, let's suppose, a mountainous area here, Gold can be present in larger chunks here. You develop a gold mine, extract it. But when we talk about rare earth elements, they will be found over a large area, present with other mixtures as well. Right? So, in this, what you need to do is you need to mine this entire region, ensure a very good filtration ability. Technology should be very efficient, and then extract the rare earth elements. That is why it is polluting as well to the ecosystem, because there are a lot of waste residues which eventually are dumped into the ecosystem, which then pollute the running water, the groundwater, and so on. For a country like China, it did not matter in the 80s and the 90s, and it went ahead with that. Rest of the world woke up very late to this kind of a technological intervention. This is the global distribution of rare earth elements. And now you will understand why China dominates this entire game. Overall, if you take a look at the reserves as per the estimates, it is close to around 115 million tons of rare earth minerals which are present. Out of that, 44 million tons is the reserve present in China itself. Okay. Then you have Vietnam at 22 million tons, Brazil at 21 million tons, Russia at 12 million tons, and India at around 7 million tons. US has around 1.5 million tons. That is why US is so dependent on China. See, Greenland is also on the list. Greenland has equivalent amount of rare earth elements as is the case with US. That is why Mr. Trump was so interested in annexing Greenland. But the good news here is that India also has substantial amount of reserves. But if you take a look at the overall production, look at it. China is producing or generating 140,000 tons of rare earth elements. Next comes US, 38,000 tons. India is at a region around 3,000 tons, which is much lesser. So the government has also been aware about it, and the government wants to extract more amount of rare earth elements. After all, in India, which are the regions where we find these rare earth elements? So there are multiple different regions in India where these rare earth elements are to be found. For example, Gujarat, right? You will find monazite sand, which has got thorium, which can be, we have discussed. In the case of Kalpakkam fast breeder reactor, that monazite can be used in the third stage, and thorium based extracts can be used in the third stage of power generation. Then, other than that, Jharkhand, West Bengal, Tamil Nadu, Karnataka, Uttar Pradesh also has got some amount. Then, Kerala, Maharashtra, Odisha, all these states have got the presence of rare earth elements. We need to extract more. We need to have better exploration. And we need to ensure that industry is also supported. Presently, the issues that is confronting India and the rest of the world is the case of the concentration of supply. Concentration of supply. So all the supply is concentrated where? In China. And China has begun to do this at a cheaper price, right? At a cheaper rate. Now, for the other countries to develop this capability, they need to invest in technology, in exploration. That appears to be expensive and time consuming as well. So, that is why all the supply chains are coming from China. India itself is importing close to around 60 to 80% of every requirement from China. And recent data indicates that our trade deficit is increasing with China. So that tells you why the world is urgently seeking to diverge away from China. And almost all the modern tech we have already discussed, from radar to defense tech to aerospace, that is concentrated there. So ability of China to produce that is much higher. That is why they are advancing so substantially in radar tech, in seekers. And that is something which is dangerous for a country which is in neighborhood of China, that is India. Now, from the side of the government, what is the policy direction? Overall, you will observe there is a three level or a three tier support for rare earth elements and critical minerals in India. Now, let's discuss each one of them. First of all, The legal framework, this is level 1. So in the legal framework, the Mines and Minerals Development Act, that has been amended. So this was an act originally of 1957 that has been amended in 2023 and 2025 as well. Then this is at the legal framework. At a policy framework, National Critical Mineral Mission has been launched. This is level 2. National Critical Mineral Mission has been launched. Okay. At level 3, support to the industry by the PLI scheme, the rare earth corridors, the rare earth permanent magnets. So that is level 3. So first frame the legal framework, then carry out a critical mineral mission. Now we will also talk about the news stories where Hindustan Copper Limited is acquiring mines in South America. Right? What is KABIL? So all of that is there in the policy framework. So first of all, let us understand the case of the amendment to the Mines and Minerals Development and Regulation Act 1957. So this act was framed in 1957 primarily with the aim of regulating and disbursing the minerals which are present, right? So development of minerals and mines to ensure orderly development, sustainable practices, and fair revenue distribution. The key components of this entire thing, it was amended in 2015 first. Now, earlier, for example, throughout the early decade of this century, there was a lot of allegation regarding the coal block auctioning, the auctioning of the minerals, the kind of favoritism being shown there. The Supreme Court had cancelled the auction of many of these coal blocks. So, mines and minerals development was plagued with policy uncertainty. One of the first or major grievances that the local population had, that the local indigenous population, the tribal population, are exploited while the minerals are being developed, right? So here it outlines the procedures for obtaining licenses, royalties to the state government, and it also established the district mineral foundation to benefit the local community. This district mineral foundation will be basically using the money gained to plow it back to the local community so that the local community benefits out of it. This was asked in the prelims examination. A direct question was framed from here. Now, who controls the minerals? So, central government, as per the Act of 1957, would control the key mineral, while state governments would regulate the minor minerals. So, as per the 1957 Act, minor minerals, so you had many of the critical minerals which were categorized as minor minerals, right? So they were allocated by the state government. Now obviously state governments did not pay so much attention to the allocation and the development of the mines. That is where you had the amendment of 2023. Now what was done, that there were certain minerals which were restricted from private participation earlier, right? They were under the atomic minerals. Now, out of the 12 restricted minerals, 6 of them were removed from the list, right? So, 6 minerals were removed from the restricted list of 12 atomic minerals, that is lithium, beryllium, niobium, tantalum, titanium, and zirconium. Now, in these minerals, private participation was allowed, which was not the case earlier. Earlier, all of this would be restricted to the government PSUs as well. And many of the government PSUs would not function as efficiently. So that is why the output was also heavily restricted. Now, allowing for private participation allowed for better efficiency, better price discovery, and also at the end of it, ensuring greater exploration. But this was not the only amendment done in 2023. Other than that, introduction of exploration license, right? So deep seated and critical minerals, right? To attract foreign investment and junior mining companies to also invest in this area. Then auction authorization, it empowered the central government now. Remember, earlier I told you many of these critical minerals were under the state government. Now, as per the amendment, it authorized the central government to auction concession for critical minerals, with revenue then being generated and flowing to the state government. Why was this done? To ensure a national coherent effort for the development of these critical minerals so that wherever possible we can extract it to the maximum amount. Then expansion of reconnaissance, that is exploration of sorts. So deep allowed subsurface exploration activities like drilling and trenching even during preliminary surveys. Earlier during preliminary surveys, digging was not allowed. Now that is why the companies would not invest. That you are telling me, the geological survey is telling me that there are 50 tons. Now, later on, I might find that there are only 5 tons, right? So, unless and until I dig it out, I get the concrete result out of it. So, I will not invest. So, that is why some amount of digging and trenching was also allowed. This was further amended in 2025. Now, the amendment in 2025, they added many or extended, enabled leaseholders to add critical or strategic minerals found within the existing lease area without needing separate leases. Even the captive mines, which had a restriction of 50% of the materials that they could sell in the market, that was removed. Now they could sell larger amount, which could make it financially viable for the companies to invest in these captive mines. Now there was creation of National Mineral Exploration and Development Trust. From earlier you had the National Mineral Exploration Trust, that was reframed into National Mineral Exploration and Development Trust to widen its scope of funding even the exploration activities. Because please understand, in this entire game that we are talking about, exploration is the key. Finding which area has got how much amount of mineral and being able to extract it in an economically viable way. Only then will it be fruitful. Otherwise, some amount, some grams, some kgs can be found anywhere and everywhere, isn't it? Now, mineral exchanges and sustainable mining, setting up of mineral exchange so that it can be sold in the market in an official manner, right? Now, then at level 2, the government launched National Critical Minerals Mission. Now it has got multiple different subcomponents. For example, increasing domestic critical minerals production. So exploration by the Geological Survey has expanded drastically. Acquisition of critical minerals assets abroad. That is where you have the news story which is developing for the past few days, that HCL, right, in final stages of taking over 4 copper blocks in Chile. Chile is one of the larger producers of copper. Copper is something where we are slightly deficient. We don't have large refining and production capabilities, but is very important as a transition mineral for rural electrification, for kind of even reliable DC connection, which is important for renewable energy battery tech. Copper is important. We are deficient in that. With the closing of the Sterlite plant in Tamil Nadu, the situation has further exaggerated. The scarcity is more, and we are completely dependent on copper from China. Now, developing effective funding and fiscal incentive, human resource development, scientific research and technological advancement, and trade and market of critical minerals. So all of this is a part of National Critical Minerals Mission. Under this, you basically have the KABIL, that is Khanij Bidesh India Limited. Just like you have OVL, ONGC Videsh Limited, similarly Khanij Bidesh India Limited. Now, this organization has been created by the conglomeration of 3 PSUs, that is NALCO, HCL, and MECL. All these three, they have been formed by, all these three have led to the formation of KABIL. It focuses on identifying, acquiring, and developing the processing of critical minerals outside India. So, KABIL, what it has done till now? In Argentina, it has acquired lithium brine blocks from where lithium can be produced, and a target of production by 2029. Acquisition has been done in 2024. It is being developed. In Australia, it has signed an MOU with Australia for joint due diligence and investment in lithium and cobalt assets, as well as domestic focus auction of close to around 100 critical mineral blocks by 2031. In the next couple of days, government is set to come up with a policy for domestic exploration and production of these critical minerals as well. Now, this is the second level. The third level is industrial support. First level, legal framework. Second level, at the level of the policy, National Critical Mineral Mission. Third level, that is support to the industry. This year, in the budget, the finance minister announced the rare earth permanent magnet mission and also the rare earth corridors. Where these rare earths are found in greater quantity, there a dedicated refining, exploration, and end to end process is sought to be developed. So, from Kerala, Tamil Nadu, Andhra Pradesh, and Odisha, all of them are a part of the rare earth corridor. Okay, this is important for prelims examination. Other than that, the government has also announced a major amount of budgetary outlay for the rare earth permanent magnet manufacturing scheme. After all, these permanent magnets are of greater utility. We have discussed that from neodymium to other minerals as well. That is very important. So, here, financial outlay of close to around 7,000 crores have been created. Additional capacity creation will be done. Incentive in sales linked incentives of around 6,000 crores, capital subsidy to support the advanced facilities, and 2 year gestation period for setup, followed by 5 year of incentive disbursement to the industries. That is what is being supported for the industries, that you explore, you manufacture, we will provide you with the financial investment which is required, because these are capital intensive industries. In the initial stages, they won't be generating profits, but they will be requiring to invest large amount of money in order to have the supply line set up, production facilities set up, right? So this is basically the rare earth permanent magnet manufacturing scheme announced by the government in this year's budget. Okay, so this is all that you need to know in this entire area for your examination. So, see, what have we talked about? What do we understand by the case of the critical minerals, right? Which are the critical minerals? We have taken a look at those: lithium, cobalt, copper, platinum group minerals, the rare earth elements, all of them are critical minerals. We have taken a look at the example as well. Then we have taken a look at the global presence of these critical minerals as well, right? Then we have taken a look at what do we understand by the rare earth elements, types of rare earth elements, the light and the heavy rare earth elements, the utility of rare earth elements. Then after that, we have taken a look at the case of the global issues in India, that is the global distribution and India distribution of rare earth elements, right? Then after that, we have understood the framework. Now we have seen in across the world which is the largest reserve of critical of rare earth elements. It is China. Then you have Vietnam. And what are the other countries that we have looked into? And what is the overall rare earth element presence in India? Let me know in the comment section. Other than that, we have taken a look at the three-tier policy, or the direction of policy in our country: legal framework, the MMDA Act, then you have the National Critical Mineral Mission, and then the PLI scheme, the rare earth corridor, and the rare earth permanent magnet. This is sufficient for the prelims as well as the mains examination. If you have liked the content, put that in the comment section below. And don't forget to click on the like, share, and the subscribe button. For more such videos, do subscribe to the channel. Until we meet again, take care of yourself. Goodbye. Thank you.